will be presented by Emma, and she will talk about Tikz or Tikz, you pronounce it the way you want. And Emma, the floor is yours.
Thank you. So hello everyone. Today we will talk about Tikz, and I will show you how to draw a platypus. And more globally, I will give you kind of a tutorial to do your first step with Tikz. So first, for those who don't know, Tikz is a language to make vectorial graphics. So for those who don't know what is a vectorial graphic, it's a graphic where you can zoom infinitely and the image will still be clear. And so this language is practical because you can type it directly in your text file. So you can also do a separate text file and include it in your main text file. But yeah, the main advantage is that will be in your file when you type LaTeX. And so for the advantages of this language, I'm going to try to convince you that it's the right language to use and that you will do this every time you need to draw something next. So first is its adaptability, because as it's a language, you will see that you will be able to change your graphic very easily by just changing a little bit of portion of code. It's also practical with slides. So if you use Beamer like me, the same things that you use to show things step by step, so uncover, pose, things like that, you can also use it in Tikz. So yeah, very practical with slides. It's also compatible with your chosen notation. So if you are writing an article in LaTeX, you will have the same notation in your graphic and in your article. So again, that's an advantage. And yeah, last advantage but not least, you have a lot of literature on it. You have a lot of tutorials on YouTube. At the end of the talk, I will give you some literature and some places to find if you have any problems with Tikz. So very practical to have a problem that you know you will be able to solve. So yeah, for the overview, so here is a platypus, if you haven't seen, if you haven't guessed. So I will show you how to draw things like that. And this platypus will just be an excuse to show you the first steps with graphics in general. So how to do graphs, how to plot nodes and edges, things like that. And then we will go a bit deeper with a platypus like this. And this will just be an excuse to show you additional functionalities. So for example, how I did this part right here. And then I will show you some advanced features. So here it will be more of a naive version of coding. And here I will show you then how to code more optimally to do more complicated things. And lastly, I will show you how to plot function. I hope I will have the time for that. But if you see this and this, you will see that plotting function is quite easy. So yeah, so first thing first, you have to import the package. So you can use the package Tikz and PGF plots. So this is for plotting functions basically, and this is for anything. And once you use your package, sometimes you will want to use some libraries, some Tikz libraries. So for example, here, if you want to do automata or trees, you can use those libraries. So this part of the code just is before your begin document. You just use the package and import your libraries. So once you've done that, you can start to create your file. So the main principle of Tikz is that you have nodes and you can connect the nodes with edges. So for example, here it's the code for making a node. So you have node A. So this just attributes a variable to your node. And here it's the coordinates of your node. and here you put the text in the node. So here you can see that the text is empty, so nothing is happening here. But if I put, for example, A in my text, I have a node that is created with the text A. And so I can kind of play with this node. So for example, if I want to draw a rectangle around my node, I just have to put draw here, and it will draw a rectangle. For example, if I want this to be a circle and not a rectangle, I just say circle here and then draw. And here I can put a lot of attributes here. So let's say I want to change the color, for example, I can totally change the color. And so here you can see that I can have 3 different types of color: the color of the text, the color of the field behind the text, and here the color of the circle, and it will appear here. Okay, so the field is yellow here, the text is black, and I draw the so the circle is red. Here I also put thick, so this just changes here the thickness of the circle around. You can also do a thick text by putting some attributes here. So basically any comment that you know in LaTeX will kind of be similar in TextEdit. So that's for nodes. Now, if you want to connect the nodes, so here I drew my 3 nodes, A, B, and C. And to connect A and B is simple. I just draw A dash B. So this connects A and B. For example, if I want to connect them by an arrow, I just have to put an attribute in row that says that it will be an arrow. If I wanted a double arrow, I would just put something here and it will draw a double arrow. If I want to have my edge that is labeled, so for example, if I have graphs with labeled edges, I can put a label around. So here I just put an argument here to show you that, again, you have you can do anything with your edges, so color, thickness, etc. And so for the label here, it will appear after this. So here you have this, and if you want to label it, you just add a node with its position. So here it's 0.3 from the start, so it will be here. And here I put it above. I could have put it below, or if my edge was more vertical, I could have used the command left or right. And here it's just the text that will appear on my label. So here I put 1. And again, it's very adaptable. You can do anything you want, basically. You can change completely the position here and here. So it's very practical. And yeah, for example, let's say that now I want a loop. So I want to connect A and A. It will not work like that. So here you can see that nothing is happening. You have to tell Tikz that it's a loop. So instead of dash dash, you just put an edge that is a loop. And yeah, you have a loop on A. And if you want to turn the loop, for example, so if you have graphs, sometimes the loop above is not convenient. You can turn the loop, you can rotate it by giving the out degree of where it starts. So here I put out minus 45. So it will come out from A from an angle of minus 45 degrees. And I put in 45. So here it's an angle of 45. So if you, yeah.
Just a question. Can you also just put edge instead of dash dash with no parameters?
I never do that, so I don't know. I never tried.
Is there a reason to do one or the other?
Actually, I never tried edge with nothing.
Just edge.
Yeah.
If you're gonna use edge, might as well use edge everywhere.
And
Honestly, I guess that you can, because, for example, when you draw something, you not necessarily have arguments in it. So I guess you can, but I never
I'm going
had
to
the.
answer.
Yeah, okay. Have a-
So if you're like a consistency.
Yeah, yeah, I-
You would put edge
yeah.
everywhere that dash.
Yeah, yeah. I understand why you asked the
Just
question.
consider that as a shortcut for it.
Yeah.
Right. Yeah.
So I guess you can, yeah, for consistency and stuff. So yeah, and so
looks like it works. So
Yeah.
I imagine
honestly, I
that-
think it works. Yeah, that's a good question actually. Okay, so that's for turning your loops. So here I put you a part of the code I used for the platypus, because now you have everything you need to draw this kind of platypus. So here I put all my nodes. So all these nodes are just for this part of the platypus. And here I used a quicker version of drawing every edge one by one. I just draw a path, and to draw a path, I just have to put my
By the
my
way,
nodes and connect them. Yeah.
this is one of the cases where you don't want to just roll.
Yeah, but you can edge.
Yeah, yeah.
Edge.
Yeah.
Don't want that.
You can do it new lines, you could have edge.
Yeah.
Just saying.
So
If you're gonna cover it, but then again, nobody wants to put the coordinates on.
I think there's a subtle difference, if I recall correctly, which is that if you do edge, you keep the same origin, whereas if you do dash every time you do. I think there's a subtle difference. If you do A, edge, B, edge, C, I think it draws A, B, and A, C.
I don't think so.
no, I don't think so. But if you want to put edge, there's also a command called path, and maybe it's compatible with the edge thing. I don't know, but I actually, so to draw this one, I used the command edge because I needed to have curvated lines. So, and it worked well with what?
Did you have a path of the edges?
Yeah, and it worked well. So I think you can do this. So yeah, so here it's just the code to draw that, but to draw this, it's the same. To draw the eyes, I just actually used nodes that I circled with rectangle, and here again it's a path. And here you can see that there is a little spaces here that are not present here. So to not have spaces, I actually just put the coordinates directly here, and it removed the spaces. I guess there is some more optimal way of doing this. I haven't tried to search for it because I thought that it was not relevant.
So
Yeah,
in fact, the reason for this is that by default, when you make a node,
yeah,
in fact, there is an inner spacing between the text of the node and the
Yeah.
contour of the node.
Right.
And so one thing that you could do is for each node to put inner set which is equal
Yeah.
to 0 parts, right?
Oh, okay.
Coordinate command, which doesn't take a final bracket because there's no content. Build coordinates with a name, and then you get.
Yeah.
Except for that, it works exactly.
So yeah, I know that there is more optimal way to do it. I didn't have the time, and it works well like this, and you
So
have this.
you're saying that there's a command coordinate that works basically like node, but without the
Without the
bracket at
bracket,
the end.
it creates a coordinate, you give it a name, and there's no set or anything like that.
I didn't know this.
This is 5 years ago. I may
Yeah.
check it out.
Probably still true.
Okay, so is this okay for everyone, this part?
Just to
yeah.
understand what you are only and the elements here. But apparently, if you got a figure, there are more notes.
Yes, so
Because she's like,
this is just the beginning of the,
Okay.
it's just for the body.
No, but you got me.
Yeah, no, it's just the beginning of the code, but the rest is the same, and it didn't fit in the slides. I didn't put it. Okay, so now we have the improved platypus, and so for example, I will show you how to do this here, how to do this kind of circles. Here we have nodes that are rotating, and also we have curvated line here, and so I will show you how to do all these kind of advanced features. So here you have the head, so it's just a zoom of the things that I will show you. I will also show you this part here, but at the end, this is just a Gaussian function actually, so it belongs to the plotting function part, so maybe won't have the time, but it would be at the end normally. So here, for the eyes, it's just a node, but instead of a text, I just put a graphic in it. So I have my eye here, and it works perfectly well. You can see that you can change the scale of your graphics, so if it's too big or too small. You can also change the scale of your node if you have a text in it. It also works well. You just have to be precautious, because if you change only the scale of a node and then you change the scale of your old Tikz picture, it makes funny jokes. So you just have to be precautious, but basically the idea is that you can change the scale of everything.
I have a question for the scale. If you want to change the scale of the whole picture,
Yeah.
something that is relative, or
Yeah. So for the scale, you actually have two commands. You will have one that changes the scale of everything, but not the text. And you also have one that changes also the scale of the text. You have several commands to do that. And I don't remember which one is which one, but.
But it's a canvas or whatever.
Yeah.
What is important and interesting is that in fact in text you can use this kind of command almost everywhere at many levels of nesting.
Mm.
And for example, when you do a begin Tikz picture and Tikz picture, you can put scale equal to 0.2 for the whole Tikz picture and environment.
That scales the text, the image.
That scales the coordinates, but it won't change the size of the text.
Yeah.
Because the idea is that you want that your text to be the same size as in the rest of your article.
Mm.
So sometimes that's not what you want, because if you scale with a small scale, and then the text begins to be too big for your graph, for example, something like
and
that.
then for the pictures that you insert in your image,
Yes.
in that image, if you change the scale of the image, you not change, because I think it is the value.
I would need to check that personally.
Yeah, it also depends of the.
Only the coordinate, but not the set of what is like the text. For me, but I don't
It
know.
would need to be checked.
So here, if you use scale like this and you change the scale of your bigger text picture, it will also act on the scale. But if you put scale in centimeters, because you can also do that, then it will stay as it is.
So I have a question.
Yeah.
You mentioned that the motivation would be that when we use this language, we can do like zoom in with the changing the picture. So when I at the end use something like this, like I'm including graphics with the PNG, for example, will the motivation still valid? Or it will also here?
No, it's just an additional feature, but.
So I use something when I. Okay, so when I have some included graphics, it will not be the same as all the other comments.
Yeah.
You have always work around with that, like you can transform these values of PNG into a vector path, and then.
This is my question. Yeah, exactly. Yeah. There's some, let's say, plus.
Okay, so here it's for the nose of the platypus. I just use this command to show you that you can put any kind of text, and that platext gives you a lot of options. And also, if you noticed on the platypus, it was rotated. So here, if you want to rotate a node, you just have to use the command rotate. So here I rotated it in an angle of 45 degrees. And so imagine that you want to shift nodes. Sometimes that's something you want to do. So you have to be precautious with if you want to both shift and rotate. Because, for example, here, if you first put rotate, so it will rotate your node. And when you do an X shift, it will be from your rotated node. And so here you can see that here you have your node here, and I rotated it from 1, but it appears on the left of the node. So if you want it to appear here, so here you want to rotate from 1 and 2, you first have to, you want to shift it from 1 to 2, you first have to shift and then rotate. So yeah, basically that's it. For the head of the platypus, I used the command arc. So as it says, it draws arcs. So here it's not cohesive with this. It's this one is blue, but this don't look at this. I just forgot to erase it. So yeah, I drew an arc with radius 1. The start angle is I guess it's not, yeah, I think it's not.
Yes, the
Yeah,
picture is not consistent with the.
yeah, it's
with
not
the
consistent with
yeah.
the text. So here the start would be 0, I think, and
Yes.
the end would be 180.
Just maybe.
Oh yeah, so here it's cohesent. Okay, consistent. Yeah, so
Maybe just back to your previous slide, that there was something interesting for people who don't know. No, next one, yes.
Yeah.
So you see here that for the coordinates, there is 3 plus 7.8.
Yeah.
Which illustrates that you can make
yeah, you can
accuracy side
directly in your.
Extremely convenient.
Another thing that's very convenient, especially when you have parts, full of coordinates.
Yes.
Yeah, you can do that too.
I don't know if you were.
I have a slide that where there are polar coordinates, I think, but in the end. Okay, so this one is consistent. So here the radius is 0.5. And yeah, this was just to show you if you want to do an arc that goes down, just have to put minus 180. And so yeah, this is for the head of the platypus. So this is just additional features to color it in blue, color the circle in a different blue, and yeah, that's it. Yes, if you want to draw a whole circle, you have the command circle. So here it's just the starting coordinates and here the radius. And yeah, if you want to draw, yes?
For arc, the coordinate is the start point of the arc, and for circle, it's the center of the circle, right? They don't match up.
No, I think it's this point here.
For the circle, the center, I'm sure that's for arc, okay. I don't remember.
Well, for
I think it's
arc,
the start point of the arc, not the center.
Yeah, it's the start. I guess it's the start because here it's here and here. So yeah, it must be the start because here it's 0, 0. Okay. Yeah, and if you want to draw several figures, the order in which you draw it counts. So here, if you draw the circle first and then the rectangle, it looks like this with the rectangle in front of the circle. But if you draw it in the reverse order, then it changes.
I have a question here.
Yeah.
Is there a way to make operations like union and difference?
Oh, that's a good question.
Because,
I don't know.
Because I mean, here you still have two entities, and then visually they are different. But if you open this into Inkscape, it will see the two different layers, right? Instead, in Inkscape, you have not only the group command, but you have also the union, intersection, difference, etc. And they become a single entity. It's very convenient because you can use that without having this thing.
Yeah, I don't know. Do you know?
I think that you can do unions, intersections, and stuff like that. I think that there are comments to that. I don't remember, but I remember seeing examples of that. So I don't think this was
for intersection. Add a mask to.
Yeah, exactly. But I don't want to really. If I want to, if you go back to the previous picture that I like better, this one, I want an entity like this, and it becomes like my ghost phantom from Pac-Man. And I want that as
oh, yes, this you can. That's just the next slide. If you want to group and act on the group, that's your question.
This is grouping. I want it to be also not different layers.
Okay.
Because this slash, I can just find a command that does that.
Yeah, I
And
know
you have
that.
one
Yeah.
command you replicate. That's how you would do it.
Not clean, but yeah, I understand.
Generally, when you have an entity you want to build and repeat, create a command that solves it.
No, sure. Yeah, this in the other philosophy, but then it's not in the like graphic designer philosophy.
Yeah.
Okay. So yeah, so about this thing of grouping, you can at least group those two things. So for example, I just define my figure, that is this. And then if I want to, for example, shift my figure, I just use the command scope, and here it will shift from 1 centimeter. So here just goes up the whole thing. So
you could even define a comment with an argument that would include the begin scope and end scope, and put the value of the argument into the square bracket.
yeah.
Or you can change the coordinates so you can do math. Not necessarily.
Yeah, but if you do that, then you will be able to use rotate and everything.
I didn't say that this part of code is optimal. It was just to show you this scope thing.
And just maybe a small remark too.
Yeah.
I think that it's considered bad to use def to define the comment, because it's a tech syntax.
Unless you want def specific.
And in particular, it doesn't check. I think it doesn't check if this command already exists, for example.
Okay.
So in LaTeX, you're supposed to use the new command, which will perform basic checks that you are not going to do something like that.
Okay. So don't copy that. Okay, yeah, and last here, so for the curvated edges, so this is the isolated part of the curve, and here you have the code. So here you have color red, and as it's curvated, you can fill it in orange, for example. And so you just, instead of dash, you put 2. You can put 2. And here you have, again, the out degree of your edge and the in degree of your edge. Yes.
So I think I know the answer.
I don't know.
I think this comes back to what I was saying. I think 2 doesn't change the origin. That's what I was.
2 doesn't change what?
The origin.
Oh.
I really don't think so. Basically, generally speaking, in text, the idea that you have, when you're giving the second coordinate here, you have 3 options. You either, so first option, you give an absolute coordinate, and it becomes the new current coordinate for what you are going to do next. Second option is that you give the coordinate with plus, so +1, +2, for example, to say that you are going to move 1 and 2 in X and Y compared to the previous one. But it doesn't change the current coordinate. So if you do something else, it will start from the old coordinate. And the third syntax is with plus, which adds also, but with the focus on the new coordinate and so on. So I really think that it only depends whether you use one of these 3 syntax and not whether you use 2 edge dash.
As far as what Remy was saying, actually, this if you use only 2 nodes, 2 coordinates, 2 edge, and everything is the same. But yeah, I replicated the thing before, like A, B, C, D, E, etc. When you do this with the dash, it goes in a circle, it goes the polygon. When you do it with edge, it always starts from the
Okay, doesn't change over.
And I think 2 changes that as well.
But again, if you have only 2 coordinates, it's the same.
Yeah, what happens when you have 5 and you do 2, 2, 2, 2?
I didn't try that.
Okay, investigate.
Yeah.
The question of what kind of model is used to draw the curves? I think it is basic curves, but just asking.
I'm pretty sure it's easy and you can change the intensity of the curve as well, which pushes away from it. Just wanted to.
Okay, I don't really know what it's used, but I just know that here you can only control the in degree and the out degree. But again, if you want to have like a very particular curve, it's just corresponds to plotting some function, and so yeah.
But it's.
This is more if you have graphs, for example, and you have multiple edges, and so you have to have a curvated edge.
Basically,
Yeah.
use often used to have some interpolation that are correction.
Yeah.
Also have explicit. You also have explicit procedures where you define components.
Okay. So yeah, now you are supposed to be able to draw this, except this part, because it's a function, it's a Gaussian function. But before showing you plotting function, I want to show you a more kind of not naive way to code, because for the moment I just show you how to draw nodes and connect them, but one by one. And here I will show you kind of an example of advanced code. It's not that advanced of a code, but it's just an example. So here you have the sun and the earth, and it will rotate like this. And so we will show how to automatize this code. So here you see that we have several things. Here we have something that is gradients. And here, if you can notice, the gradient changes. If it's far from the sun, it will be less yellow here. And if it's close from the sun, it will be more yellow. And so there will be a part of code to do that. And yeah, that's it basically. So here, you have to set up some things. So here it's just the sun. So first, this example, I didn't draw it myself. I find it on the net. So just to be clear about that. So here you have just the sun radius. So it will be 0.3, the earth radius. And here, the eccentricity of the elliptical orbits. And here, the minor radius. So this is just the minimum radius. So yeah, so this is just to draw the sun. So this part here, visible, the common visible, it just say that it will be visible on frame 1. So this is just for the label sun. So this part is for label sun. The shading angle just says that it will shade from an angle of 45 here. Those are just for the two colors that will be shading. And this is just to say that you draw a circle, okay, with coordinates here and radius here. So this is just the part to draw the sun. Now it's just to draw the ellipse. So here it looks like a circle. I don't know why, but it's supposed to be an ellipse. And this, yeah, so this computes the direction in which the light will hit the earth, depending on the position of the earth. So here you can see that you can declare a function. So that's what I mean by advanced version of code, is that you can actually declare a function and execute them in your code. So you will see in the last slide how we execute all the functions. So here, yeah, just a function to compute the direction here. So it's I haven't got into the details of this, so I cannot say why it's true, but I guess if you do a little bit of trigonometry, you will understand. Yeah, so this is for to compute the distance in order to shade correctly here the color of the earth. And here it's the same thing. I just wrote it twice. I don't know why. And yeah, so now this is for producing every frame. So we have this for each here that will compute every frame. I didn't put here the code, but yeah. Normally you have this visible one, which is again just to put the little text earth on the frame one. But here, if you remove it, you have this. Yes.
This is a beamer specific, right? That doesn't work like that.
Yeah, this is for beamer, obviously, to do frames, but the only beamer option is here, actually on slides. And if you wanted to, for example, just draw a lot of Earth, you just remove this on slide and it will draw every node. Yeah. So really the main command is this for each that permits you to automatize your code. So that's why I put this example. And so here, yes, you have theta. So I guess, yeah, here you have polar coordinates, I think. Yeah. It's Tikz, I think.
No, it's general.
Oh, it's general.
I don't use it.
Yeah, okay. But where do you use it then?
You can use it in a CSV.
Okay.
And you
yeah.
check for each
Yeah,
line
okay.
in the CSV.
Yeah, okay.
So, yeah.
Okay, so yeah, I won't go into detail, but basically here you just compute your theta. So this part is just to compute the position of your Earth here, and then this is to draw your Earth, this on every slide. Okay, and then it turns. Yeah, I have the time to plot functions. So here is an example of plotting function. So here with the grid with different colors. So yeah, let's analyze the code. So here you begin your text picture. And oh yeah, I never showed this command actually, I think, but that's the command you use to write your code inside. Begin text picture. And here you have an argument here, which is the domain, so 04 here. This part of the code is to draw the grid. So just this grid here. And you can see that here it starts to minus 0.1, so just starts here. This two is just to draw this. I guess there's a more optimal way to have directly your grid like this. I don't know, with the arrows. But yeah, if you want to do it simply, you can do it like that. And yeah, to plot, you just have to use the command plot. So that's very simple. Here you have your variable and here your function. So for f of x is x, you can see that it's just /x/x. For more complicated one, you have /x. And here you just have this little thing that you don't have to forget. And you just put your function. So yeah, sometimes the commands are not completely obvious, but you have a lot of literature on the net if you don't remember if there exists a command for log, for x, etc. There is one, but if you don't remember which one it is, you can just search on the net and you will have. Yeah.
So I suppose that the initial domain is for all the dots that you but if you want to have some code, the domain that is different from one to the other, can you also declare domain closely to
that's a good question. I didn't need to do that, so I don't know.
Specifically, but
yeah.
Usually just
I guess you could still put the domain maybe here, actually. When you plot directly, maybe in here. That's my guess, but I'm not sure. But I think you can, that should be possible. So yeah. And yeah, so that's it. So here for this, yes.
Why maybe to do that? Imagine that you want to have a curve with different definition in the
Yeah.
So yes, I confirm we can put domain in
here.
row. Yes.
Yeah.
But it's very consistent with the general philosophy of text. Where generally you can do things like scope, rotate at each level of nesting. In fact, you can put that directly for the command. You can put that for the whole text picture, but I guess that you could also do that for a scope, for example, which is very convenient for a number of functions, and do something else for another number of functions.
But that's one thing that is very convenient with Tikz, is that if you wonder, can I do that? The answer will generally be yes. So you just have to find on the internet how to do it. Okay, so for this part, you can see that the curve is rotated. So I just wanted to show you the command to rotate curve. And so here you just rotate it in the draw. So this is the Gaussian, so this part is for the Gaussian. And again, you can fill the color. You can also, so here the color is orange, both on the top and on the fill. And yeah, and also I just wanted to show you that you can also shift your curves, because I needed to shift it, because when I drew the curve, it appeared on the left side of the figure, and I wanted to shift it, so I just used the command X shift and Y shift. Just, it's the same command as for the nodes. You can also shift your function as well. Yeah, so now do we have time for this? We have a little time. I would just tell you that there are some useful packages. So for example, if you want to do automata, trees, you can use those packages. Pattern is just a package to, for example, here, if you don't want to fill it completely, but you want to have a dashed filling, you can use the package patterns. And this is a package that I thought was funny. I wanted to put an image of Petronet here, but I didn't have the time. So just imagine there is an image here. So the trees, so this is the code for trees. I won't go into details, but you can draw a tree basically by saying which one is your main node here and which one are their child. So it's just it's actually very similar if you want to code a tree in any language. Actually, it's just this syntax. I don't know if it's the optimal syntax, but you can do it by hand like this. Again, I guess you can automatize it. For automata, it's the same thing. Basically, you have, you say who is your initial node. So here, my initial node is here. Who are your other states? And you can say if a state is accepting or not. So those two states are accepting, and it will have a double circle. And again, you can draw path between your states. So this is very, very similar to the things I showed before. It's just that it's a bit quicker to use the automata package, because you can have this notion of states that are accepting or initial. And yeah, that's it. So for some resources, you have the PGF Tikz manual online. It's very complete. You have a lot of things there with a lot of examples too. So it's very practical to learn. You also have the LaTeX Wikibook, which has a PGF Tikz subsection. And again, it's quite complete. You have a lot of tutorials on YouTube as well. And if you have any questions, usually the answer is on Stack Overflow or in the three things here. And that's it. Thank you.
Maybe I want to do 2 remarks. So for French-speaking persons, there is also Tikz pour l'impatient, which is a very nice resource to just as a long tutorial or a short manual for text. And my second remark would be that in Python there is a very interesting package that is called Tikz.lib, which allows you to export matplotlib figures to a text. Actually, currently there are some small problems of compatibility with the matplotlib 3.8, which is the last version of matplotlib, but I hope that it will be resolved soon. And anyway, in the worst case, you can still use matplotlib 3.7. And that's it.
Yeah.
Just to finish the question about dash dash two.
Yeah.
I checked it already. So the equivalent of dash dash one options is 2.
Okay.
Okay.
Edge is a weird thing that does not change the origin when you add anything, which applies the thing to the previous state doesn't change the thing.
Okay.
So you should be using 2 generally if you want to have
Okay.
that. That's it. I also wanted to add a thing that's I found quite useful is you can define options that will apply styles.
Yeah.
So if you have a style you want to apply to many different places that you may want to change later, you can define an option. I don't remember what the command is. And then every time you put that option, you change the style. That's very useful when you start having when you want consistency across your slide.
Yeah.
It varies.
And also another thing to add is that there is a package that's called Internet Networks. I think it simplifies the nodes that you want to use because you just need a CSV file and it will you just say import CSV and it will plot with that. Because I don't like to write nodes manually.
Yeah.
Another thing that I'm looking for that I still don't know is that sometimes you are not interested in the coordinates of the nodes, like with PHP libraries or D3 or I don't know, chart.js. You just have a bunch of nodes and connections, and then you tell the tool plot this. I don't care what, and then it can draw the nodes around. Do you know if
I was thinking about there's some converter, you just like draw a sketch of the classic image, it can just then share with you the code. That, like for example, in Latin, when you have an equation, let's say you have an image of an equation, there are some tools where you put the figure and then it gives you the Latin syntax. So is there something similar here? So there's like, for example, this figure, I share a figure, and then there's some converter who propose some code, text code, and then you can modify it if you want. But is there something like this?
I would imagine that you can do it in 2 steps. Something that converts that to SVG, pretty sure you'll have an SVG to check that is probably something you'll find.
Okay, if you still need 2 steps, what I would like is, I give to a package a list of nodes and their connections, and then this package, without any other help, it just plots, according to me, is the optimal.
It's what the tree does.
Well, no, the tree you still need to say child and
Yeah,
child.
child is the connection. You're not giving.
It's just giving the topology. You don't need the actual
But
layout.
the example that we saw before, you still need to write child. Is there a way that you can code a tree and you import this here?
You can. I don't know there's a built-in package for having a tree given by something else that would really depend on the format. But at that point, you're just giving the topology, you're not giving coordinates.
No, I know, but I mean, look at how much redundancy is there in this code. I see child written 10 times, so.
There's not really redundant. If you indent it, it looks normal. Because child just means there's an edge. You're gonna have to define it some way or another.
Yeah.
Well, I kind of like what we can do with draw node because you just say dash and you connect the node.
How do you do that when you have multiple children? That's exactly what it does. This is it's a node, but it's a draw hidden.
It already wants simplification. I like that. But again, here, first of all, you have only trees and sometimes you want graphs.
Yeah.
So
something else.
Yeah.
But
But this you can change how it looks by doing it. Here it's just by default it looks like that, but you can also change how it will look with branches above and things like that. You couldn't play with it, but yeah.
Sometimes in automata is also we have in general that if you have the automata spot where you can say this node is just to the left of that node, not specified. You want something that actually lays out your graph just from the graph topology. I don't know.
It's more complicated because you really need your optimization algorithm.
Yeah, I'm doing that is generally some weird algorithms you have to find, because there's no like default algorithm.
yeah, exactly. But I mean,
I would imagine some people have small things like that. Paint is putting it in latex. It's generally painful. Having codes and algorithms in latex.
And very often it's convenient, by the way, to generate text code, for example, with Python.
Yeah.
because you have some, I don't know, you have some algorithm that you have written in Python and you want to illustrate how it works for your pod, and just convert the output of the algorithm into the text that.
Even if you don't go that far, your graph, you have your graph, like it's generated by Python, you would ask Python to decide where to put the nodes, because Python would do it better than that.
Other questions, remarks? Okay, thank you.
Yeah.
It's very useful for, you can specify node locations or coordinates between two different 2D pictures and then plot them together. It's very useful when you have like text that wants to point to something in a picture. You can actually specify those coordinates and use them together. I don't remember what the syntax, but it's useful.
And maybe another remark also is that text can be very well connected with another LaTeX package which is called Animate to create animation with text textures, for example. And it's of course especially useful when you prepare slides and include animations in your stuff.
Yeah, but this one I tried to use it to show you, but I had a bunch of errors. So
yeah,
it's a package that
work.
Yeah, it's a package that is a bit hard to understand, especially when you have errors. But yeah. In the end, it's very, very cool to have animation. I wanted to animate actually the Earth and the Sun at the beginning, but yeah.
Thank you again.